So first we'll see about D and L isomerism. Based on the orientation of H and OH group on the which carbon? Fifth carbon, that means penultimate carbon. Based on the position of these groups in the penultimate carbon, we'll either call it as D isomerism or L isomerism. If the OH is oriented to the right side, we call it as D isomerism. If it is oriented to left, we call it as L isomerism. So this is one form of isomerism. Next we'll see about optical isomerism. In the optical isomerism, we'll pass a beam of light. Okay, we pass a beam of polarized light. You can see a polarized light passing through the sample tube containing a carbohydrate solution. If the carbohydrate solution rotates the plane of the light to the right, we call it as dextrorotatory. If it rotates the plane towards left, it is called as levorotatory. So optical isomerism consists of dextrorotatory and levorotatory. So when it rotates the plane of the light to right, it is called as dextrorotatory. To the left means it is called as levorotatory. So we have seen D and L isomerism as well as optical isomerism. Next we'll move on to epimerism. What is epimerism? Epimerism means this is also based on the position of hydrogen and hydroxyl group around the carbon atom. But other than the penultimate carbon atom, other than any other position, other than the penultimate carbon atom, we call it as epimerism. For example, this is your D-glucose. This is your D-glucose. You can see the H and OH positions are changed in the second carbon. Then we call it as mannose. It is the second epimer of glucose. If there is any change in the hydrogen and hydroxyl group in the position at fourth carbon, we call it as galactose. So it is the epimer, fourth epimer of glucose. This is called as epimerism. Next we'll move on to anomerism. Anomerism means so the glucose exists in the ring form. You can see the glucose existing in the ring form. Here it occurs in the hemiacetal ring form. So between the carbon 1 and carbon 5. So based on the arrangement of OH group and H group on the carbon, first carbon, it is called as anomerism. If the OH is below the carbon plane, we call it as alpha glucose. Whether it is above the plane, we call it as beta glucose. So it exists in two forms, alpha glucose and beta glucose, based on the position of OH and H group around the first carbon atom when it exists in ring form. So we have seen all the four isomerism, that is D and L isomerism, optical isomerism, that it means either dextrorotatory or levorotatory, epimerism, and last anomerism. Next we'll see about the mutarotation. What is mutarotation? So mutarotation means it is change in the optical rotation by the interconversion of alpha and beta forms of glucose. Mutarotation means it is change in the optical rotation by the interconversion between alpha and B forms. Glucose exists in alpha form as well as in beta forms. So when a solution is prepared, it may exist either in alpha form or in the beta form. So when the alpha exists in the solution, it gives a rotation, optical rotation of plus 112 degree. When the solution contains a beta form, only the beta form, it is present in the optical rotation of plus 19 degrees. Okay, it is approximately plus 19 degrees. So, but after some time, actually when it is freshly prepared, the alpha shows the rotation 112 degree, the beta shows the rotation plus 19 degree. after some time, after 24 hours, if you see the rotation in the solution, it produces plus 52.5 degrees rotation. So this is because there is some interconvention between the alpha and beta forms. So they interconvert and obtain an equilibrium form. So they exist in equilibrium mixture and produce a rotation of plus 52.5 degree. That is nothing but your mutarotation. Okay, in this you can see both undergo mutarotation, and at equilibrium they produce a rotation of plus 52.5 degrees. Here mostly the solution contains beta type. 2/3 contains beta type, only 1/3 contains alpha type. Okay, this is what mutarotation is about. Next we'll move on to reactions of monosaccharide. We have seen the properties of monosaccharide, that is nothing but your isomerism. So we have finished the isomerism. Next we'll move on to reactions of monosaccharide. There are two things. One is to identify the monosaccharide. Second thing, the reactions which give some biological action. Okay, identification is done by with alkali, acid and phenyl hydrazine. Okay, with alkali, the monosaccharides tautomerize to form an enediol.